Okay. So let me introduce our today's speaker. Lieutenant Colonel Keirin Joyce is the Royal Australian Air Force Remotely Piloted Aircraft Systems RPAS Sub-Program Manager. Previously, he was the Australian Army UAS Sub-Program Manager responsible for all Australian Army UAS activities. LTCOL Joyce is an Australian Defence Force Academy graduate in Canberra with an honours Bachelor of Aeronautical Engineering, and he has spent the last 14 years in support of the ADF UAS capability, including deployment to Iraq and Afghanistan. LTCOL Joyce is a chartered professional engineer and holds master's degrees in Aviation Management, specialising in human factors, aerospace engineering, and in military and defence studies. In addition, he is currently a part-time PhD student at ADFA. And personally, I had the opportunity to be a student member for the Royal Aeronautical Society Canberra branch, which Keirin was heading when I was in the committee, and that was an absolute pleasure for me to be in that committee. And I'm very thankful for Keirin to have accepted this invitation to present to the Aeronautical Society of Nepal. And with that, I will leave the podium to Keirin for his presentation. And please ask your questions on the chat box on the side, and we'll go through them in the end. Okay, it's yours, Keirin.
Hello, and hello, everybody. It is my absolute pleasure to be here presenting to you all. I can happily say that this is a bit of a reciprocal effort. Sudip gave us a lecture on establishing the Aeronautical Society of Nepal a little while ago, and it is fabulous to hear what you have been through, what your academic growth and your university growth has been through, and it's certainly interesting to hear that the Nepal Air Services and police services are very interested in this kind of technology and want to grow how they use it. So so welcome, everybody. I'm very, very happy to be here. I'm just going to share my slide window now. So the scope of my presentation, slides are built on an Army template, but like Sudip said, I now work in our Air Force's headquarters, developing their remote pilot aircraft systems program. So they're built on Army slides, but I'm going to cover as much as I can: Army, Navy, Air Force, drone racing, innovation, and research and development, and future concepts, things that we're thinking about for the future. Context setters. The Australian Army is Australia's biggest, most experienced and safest drone user. We now have 3 systems fully in service, another 2 systems in use, so in trial or in limited use. And that sums up to more than 1,000 drones and more than 1,000 operators across our Army. Our people use drones in a variety of employments. Specialised UAS operate within our UAS regiment, which is based in Brisbane. We have non-specialised drone operators, so the infantry, the cavalry, combat engineers, anybody else that might use a drone to support their full-time skill set. And we do it for fun as well, and we drone race. Our Navy is experimenting with drones, in particular the Scan Eagle and the Sheeble S100, and they have established a UAS operating unit in New South Wales, and they're on a pathway towards a major project and setting themselves up with in-service capabilities. Our Air Force is experiencing, so it is experimenting, but we call it experiencing because we have embedded our people in the United States Air Force and in the Royal Air Force to learn the lessons about how we're going to do remote pilot aircraft systems operations within the Australian Air Force. And we are establishing those units, those people, towards a project a couple of projects that I'll talk about. What all that will add up to is by the mid-2020s, the ADF, the Australian Defence Force, will be a very unmanned force. And our latest defence policy statement, the Force Structure Plan 2020, has articulated a significant expansion into the 2030s with uncrewed technology. I'm not quite sure dollar translates to your currency, but in Australian dollar context, we are slated to spend more than $30 billion in uncrewed, unmanned, remote, and autonomous systems into the 2030s. So that's the context in a nutshell. But what we'll go through is talking about all of those things. I'm going to try and do that in about 35 to 40 minutes. And then so we'll start with the very smallest. Our nano unmanned aerial system that's in service is the Black Hornet. It's the Black Hornet 3. We have been a Black Hornet user for quite a while, for over 5 years now. And we started with the Black Hornet 1 version, the initial version. And we built that up. So we bought about 10 Black Hornet 1s. We really liked the technology and where it was going. We brought that up to 25 systems with the Black Hornet 2. And we absolutely made our mind up that this was a force multiplying piece of technology to our combat platoons. And then over the course of a year and a half, 2018 to 2020, we built that fleet up to 175 systems. And each system has 3 aircraft in it. And those 175 systems have been distributed to every combat platoon and every surveillance and reconnaissance team within the Australian Army. That gives those soldiers the ability to see out to 2 kilometres, so down into city intersections, around the corners of buildings, over the hills, down into creek lines, out to about 2 kilometres worth of reconnaissance capability. There is a day version and a night version, so they are supported 24 hours a day, and each aircraft stays up for about 25 minutes. And it's got a 3 aircraft system capability, so that you can go out, bring it back 25 minutes later and put that one on to charge, and then by the time you do that once more, twice more, that first aircraft is recharged. And you can essentially just keep going for as long as you can keep charging those aircraft. Now this kind of technology has a very short life of type. Already you saw the Australian Army experiment with 3 different types, 3 different models over only 5 years. So we have identified that, and we've given this a fairly short life of type, and we've already made the decision to replace this system. A project called Land 125 Phase 4, that's how we number them. In only a few more years' time, we'll go and we'll look for we'll compete a tender to replace the Black Hornet 3. It's a very exciting capability. The soldiers love it. It's very fun to fly, and really neat technology. Stepping up, we have the small unmanned aerial system. The one we have brought into service is called the Wasp. It's made by AeroVironment. Again, we got into this system by trialing. So 6 years ago, we bought a small quantity, 14 systems, brought them in for a trial. And over a couple of years, we made our mind up that that was the system, the type of system that we wanted. Then we had a competition, and this aircraft won the competition. It is hands down the best small UAS you can buy on the market. It still is, 5 years later. It is the only fully waterproof system, so we can, our waterborne troops or our amphibious troops can literally land it in a dam, in the ocean, in a creek, and be assured that it will still work when you change the batteries out. So fully waterproof, day and night in the same gimbal, And because of the aircraft design, it is a traditional aircraft design, we get significantly more endurance out of this aeroplane. So 45 minutes. That gives us the ability to go out to 5 kilometers and spend a reasonable amount of loiter time out there. Each system comes with 2 aircraft, and we've built those systems up to 68 now to be fully in service. So, 140 odd airplanes, but 68 systems, and this augments a combat team. Now, a combat team is a company worth of soldiers, so about 100 soldiers, and their sphere of influence is about 5 to 10 kilometers on the battlefield. So we bought them a 5-kilometer unmanned aerial system, and that supports the combat team commander. That introduction into service is fully delivered, and we have another test and evaluation campaign to roll through once we are conducting major field exercises again after COVID. But we'll do that last round of test and evaluation, and then the project will be finished. Again, we've made a call that this is going to be a short life of type, and we've already scheduled a replacement program in the early 20s to buy a new one of these types of aeroplane. This is an interesting one because our government has recognised that our universities and our industrial base have the capacity to build something like this. And so we have undertaken an industry seeding activity where we're trying to help Australian industry compete this one for when we run that competition in a few years' time. I'll talk a little bit more about that on my last slide about how we're supporting Australian industry. The next size up, so combat team is 100 soldiers, about 10 kilometers worth of influence. The next unit size up is a battalion or a battle group. Now, battalions and battle groups, they have 400 to 600 soldiers in them, and their ability to influence is 30 to 50 kilometers. So battle group headquarters in the middle of that, we want a 20 to 30 kilometer unmanned aerial system. And that matches up really nicely with our offensive capabilities because a battle group is allocated an artillery battery to support them. And our M777 artillery shoots out to 30 kilometers. So we really want to be able to give that commander the ability to look for targets out to 20 and 30 kilometers. We have a small quantity of the ones on the left. That's the AeroVironment Puma. But we've been trialing those, and you may have seen that we have deployed those. They have deployed to support operations in our region, and we've deployed them offshore when we helped provide security forces to Papua New Guinea for a major meeting of government heads. That was one of the systems we deployed to Papua New Guinea. But we have experimented with the one on the left, the Puma, and we're running a competition right now, actually, between, it was an open competition. We had 9 tenders. We brought 2 into a fly-off. The one on the left, the Puma, and the one on the right is the Elbit Systems Skylark. We've run that competition, and we're making our decision now about which one we're going to buy. It shouldn't be too long before that's in the news about which one we're going to buy. Both of these can operate in all weather. Both of these can operate for more than 2 hours, more than 20 kilometers. And obviously with a bigger aeroplane and more battery power on board, you can do a lot more. The sensor packs that are on board these systems are even better because they get bigger, space weight and power goes up. It's a very exciting competition, and we're looking forward to introducing those into service next year. Our oldest UAV is the one on the right here, the Shadow 200. This was our first UAV into service, our tactical unmanned aerial system. It supports a brigade, and we brought that into service almost 10 years ago now. We did that in cooperation with the US Army, who are absolutely the biggest user of the Shadow 200. They have more than 100 systems of this. We bought 2 systems. That gives us the ability to support a brigade that's deployed, and also to be able to train our people and another brigade who might be relieving that brigade that's deployed on operations. 2 Shadow 200 systems. This is the spot where we use specialised operators, these unmanned aerial systems operators. That's what they do for a job. They blokes and girls soldiers and officers all trained on this equipment, and that's their job 365 days a year. It's already getting old, and the technology on board, while really awesome, like every time this aeroplane goes up, it's carrying electro-optics, cooled infrared, a laser designator, and a comms relay payload, a communications relay payload for our combat net radio. But like I said, it's already getting old, and we want to provide an even better system that can reach out in the brigade sphere of influence out to 100 kilometres. This is a 9-hour aircraft. We think that's about the minimum that we'll be shooting for. We want something with longer legs, so it stays up for longer. We want it to be quieter. We want it to not need a runway, because a runway is very tactically constraining for a brigade commander. And we have a fairly significant amphibious operations capability within the Australian Defence Force. So we want it to be able to fly off those landing helicopter dock ships. We also want it to carry even more sensors. So we are looking for our replacement system to carry, to have an advanced payload bay where we can put other things in as well. And we've learned a lot about what those extra capabilities can be through an experimentation campaign. So while we were making our tendering decision and writing our requirements documents, we did a lot of experimentation. One of the platforms we experimented there is in the middle, the Schiebel S100 camcopter. It is a very heavy lifting truck. You can fly up to 4 different payloads on this at the one time, and we've experimented with hyper and multispectral payloads, with synthetic aperture radar, with electronic warfare sensors, and we've made a shopping list of things that we're going after. That competition is open right now, and 4 different companies are being evaluated as we speak. The tender evaluation period is open, and we're making our decisions about how to progress that towards spending the money that is in Land 129 Phase 3. And by the middle of the 20s, we'll have retired from. It'll be very exciting for the UAV regiment to go from, what is essentially 3rd, 4th generation technology in the Shadow 200 and step up to a 4th, 4.5 type generation of technology in the replacement program. It's very exciting. So those were our in-service capabilities, and I covered off on one of the in-use capabilities, the Puma. The other in-use capability is our commercial capability. So I talked about those in-service tactical systems, the ones that are painted grey. We call them the grey drones. Military specification, quite expensive. We could only afford so much with the budgets that we had. But we recognised that many other units would like drone technology and could become more efficient and more effective if they had drone technology. So we've run this experimentation campaign over the last couple of years using DJI products. So the best commercial product, highest resolution cameras, easiest to operate, easiest to train, very easy to sustain when it breaks. You don't need to go into a military supply chain. You can just go to your local electronics store and buy new components or get it repaired. So we bought a very large buy, more than 350 systems. We developed a training package that's very similar to the DJI training package that's just available on their YouTube channel, and we rolled this out to the entire Army. So all of our cadets, so we're talking about 13, 14-year-old kids that are in the Australian Army Cadets. So all of our cadet organisation have this. We rolled it out to the full-time Army, every single unit. We rolled it out to our reserve Army, our part-time Army, every single unit. And we trained, we've now trained more than 1,000 officers and soldiers and cadets across the Army in how to fly the DJI Phantom 4 Pro Plus. You could tell it's the Pro Plus because it has the integrated control screen in the controller, so it's not a separate controller. That is one way we mitigate any cyber vulnerabilities. We don't have a controller that's got a Wi-Fi link. And this has been a highly effective program. So not only can we do counter UAS training, because some of our threat forces out there in the world, they fly these types of things against our forces. So we can do counter UAS training. It has an Ultra HD camera, so it's really great for unit training review. You fly it over the top of your soldiers while they're doing their infantry or cavalry training, and then you can do really great debriefs afterwards. And then drone literacy. So like I said, more than 1,000 soldiers now understand drone technology. They know the components, they know how they work, they know how to fly them, they know how to employ them and experiment with them. So we've had a really great drone literacy program and taken the negative tarnish off the word drone and turned it into a really positive thing. So soldiers are now thinking very positively about how they would apply this technology to the jobs that they do. And we've used it for experimentation. So like I said, a lot of people wanted to improve their tactics, techniques, and procedures, and they've been able to do that now with cheap, easily accessible technology. And it's been a really exciting program. We should see the results of this over the next couple of years as each of those units write up their reports about how awesome the technology or how much efficiency they got. You know, they'll send those reports into the headquarters, and then we'll be able to use that to buy the next generation of tactical systems, systems that they can employ operationally into the future. Super exciting project and really easy to get after because they're so cheap and so easy to train. So I'll talk about some of Army's conceptual development work now. So we're really interested in logistics UAS. You know, if a combat call sign is out in the field and they have something break or they run out of supplies, you know, a priority demand, that's what PRIDEM stands for, a priority demand. At the moment, if they're in a really isolated location, we have to send a helicopter out to do that, an MRH-90 Taipan helicopter. Now that helicopter is worth $30 million and it's got 4 to 6 people on board. You know, that is a very expensive value proposition when you could send a very cheap and unmanned aircraft to do that combat resupply for you. So we've been experimenting with 2 types of drone. The ones up in the top right, they're just exemplar pictures of things that Israel and US Army is doing. The ones I want to draw your attention to are the ones down the bottom. The one on the left is the first dot point that I'll talk about. So a combat resupply unmanned aerial system. So we have landed on a figure of 150 kilograms. Why? 150 kilograms is a very useful combat load. That's a lot of bullets or a lot of water, a lot of first aid supplies, a lot of fuel. But more importantly, once it empties out at that call sign, you know, if they have a casualty that needs evacuation, well, that is the kind of weight that a soldier with their body armor, with their weapon, could get into that aircraft or be put in the aircraft on a stretcher, and we could remove those soldiers unmanned back to a casualty collection point. So that's why we've asked for at least 150 kilograms worth of lift. That airplane on the left, that is being developed in Sydney by a startup, joint sponsored from a funding perspective. They you know, defense is paying for some and venture capital is paying for the other, because you can see it's a sexy looking commercial aircraft. They want to use it for the urban air mobility market. But what we're paying them to do is have a look at the military aspects. You know, if we painted it green or grey and had it in the Australian Army, well, what would those military aspects look like? So how does the cabin change to be able to take people lying down on a stretcher, wounded people, instead of people sitting up and moving around a city? How do we give it redundancy in navigation? So in a city market, you know, differential GPS is awesome and you can assure it, but in a military context, GPS might not always be there. So we're looking for redundancy in navigation, in landing systems and the like. So that's where we're funding, and that's really exciting. That's prototyping at the moment, and we'll start its test flight campaign later this year and roll into next year. The one on the right is a company in Melbourne. We asked this company to scope out the very cheapest drone that we could possibly build to move small quantities around. So if a part of a weapon system breaks, if a component of a radio breaks, what if you need just some batteries or
Hi, Keirin, can you hear us? I think we lost you there. Okay, apologies, everyone. Let's wait for a while. I think we lost Keirin there. He should be back quickly. Was everyone else experiencing this problem, or was it just me? I believe it was everyone else.
Hi everyone. I think my internet dropped out.
Yep. I was wondering whether it's me on this side.
No, I think it was me. It's jumped. Now, where did I get up to before I dropped out?
We were talking about the logistic UAVs, and
Yep.
we were just about to touch upon the fact that you want to make that blue commercial UAS green and sexy.
Okay, green and sexy. That's
Yep.
where we're at.
All right, that's where we'll start.
Okay. All right. So, green and sexy, co-venture, and Army's part is that we're paying for the military applications. How do you change out seats for a casualty evacuation stretcher? How do you make its navigation systems redundant, because military operations don't always have perfect GPS? That's what we're doing with that one. The one on the right is a cardboard drone. It's disposable, and that has been developed by a company in Melbourne. It comes as a flat pack, IKEA style. So 30 drones flat packed onto a pallet. The soldiers are taught how to assemble them, literally with hot glue, masking tape, and elastic bands, and they are essentially disposable. And you can throw 3 kilograms around the battlefield. Specialist medical supplies, batteries, weapon repair parts, things like that. It's a very exciting piece. We've fully proven it, and we're looking to take that the next step, which is fully integrated, so that the Defence Force can buy them and use them. Or maybe they can tap export markets through non-military means as well. Red Cross and humanitarian response organisations are really interested in cheap, disposable, massed UAVs like this, where they could throw emergency rations or emergency first aid supplies around emergency zones. We're also interested in pseudo-satellites. I said before, you know, sometimes in a military scenario, we don't always have our GPS accuracy. So we also don't have other satellite services because they can be jammed. Our enemy or our threats and adversaries can take them away from us. So we are interested in pseudo-satellites, putting up our own ultra-long endurance, ultra-high altitude systems that can stay up for many, many days. We have an agreement with our Defence Science and Technology group, and they have a contract with Airbus. One of their global test sites for the Airbus Zephyr is in Australia, in Western Australia, in a place called Wyndham. So we're joined with them on this experimentation campaign to understand how you can go. We're also interested in swarming. We have a couple of companies in Australia that are also partnered with our Defence Science and Technology group, working with partners in Singapore, in the US, on the problem of the contested urban environment. So again, places that are very hard and very dangerous to operate in and hard to operate in, places where GPS isn't always great, where visibility isn't always great, where you can't always guarantee line of sight for your control links. So we're really interested in high levels of automation and swarming robotics. The approach is a cross-program approach. It's not just about the flying thing. We're working with our Soldier Combat Systems Directorate, our ISR Directorate, our Communications Directorate on what this looks like. And we really want to stay at the edge of this because we know that there are many countries investing this kind of technology, and we do not want to be left behind when it comes to swarming small unmanned aerial systems. And then lastly, we also do it for fun. So the Australian Army drone racing team has been one of our sports teams for the last 3 years. It's a new army. Not everybody wants to play rugby or AFL or cricket. There are plenty of young soldiers, young officers out there that are interested in cyber sports. They're interested in wargaming, in white hat hacking, and drone racing. Now, this is really interesting. So we started the team so that we could support our soldiers in their hobby, but very quickly we realized that there are other benefits to a team like this. It provides us a really easy mechanism for engaging with our youth around Australia, for inspiring them towards STEM studies, science, technology, engineering, and maths studies, because these airplanes are designed, built, crashed, flown, and repaired by these people as a hobby. You know, and they don't go to university to learn how to do it. They don't go to a technical college to learn how to do it. They don't take electronics classes to learn it. They teach themselves in clubs with YouTube videos. And I think that's really exciting, you know, really new types of hybrid learning amongst our young people. So we can do that inspiration piece and have those conversations. That obviously allows us to have a discussion and letting them know, letting drone racers and other kids interested in STEM all around the country know that the Australian Defence Force is a place where if you really like this, you could fly drones for a job. You can be a remote pilot, you can be a UAS operator, you could do it part-time, so maybe have a mashup and pick one of those trades that sometimes uses drones, like the infantry or the cavalry, or, you know, you could just do it because you might want to be something else. You might be a musician, or a cook, or one of those trades that does not use drones for their job, but you still might like doing this thing and you can still be in the sports team, and that's really cool. We liked it so much that we had the first military international drone racing tournament, that's MIDRT, in 2018, and we invited a bunch of countries down to Australia, and we had the first competition, competition for drone racing, and that was great. You know, New Zealand came across, England came across, we had teams from Thailand, we had people from the Emirates, we had people from Malaysia and Holland all come and have a really good, friendly, competitive competition. We won it, and I'm so excited about that. You know, that community got together, had a really good time of relation building, really geeky tech time as well, and we're really looking forward to the next competition. So that's Army. Navy. Navy is doing a lot as well. I'll start quickly by saying Navy has just had their drone racing team approved. So I don't have any photos of them yet. They're very new on the scene, but they are in that game. Navy have also experimented with the DJI Phantom 4 for doing missions, overwatch of boarding parties, things like that. But this slide is really the exciting game that Navy is in at the moment. Navy is really interested in systems like the smaller one on the left, which is the Scan Eagle, systems that can support patrol boat and corvette operations. And they're interested in bigger systems like the Camcopter S100 from Schiebel for supporting major fleet corvettes and destroyers, augmenting the weapon systems of those platforms. So they have a squadron. They are full-timers. That's what they do. They have a couple of Scan Eagle systems. They have a couple of Schiebel S100s. They've deployed into the region around Australia. They've sent the Scan Eagle off on anti-piracy operations. They've sent it to the Middle East on our ships. They're learning a lot, and they're heading towards the top of that arrow, which is an enduring capability, which is a project called C129. And in the mid-20s there, they will bring into service a significant quantity of fully integrated equipment to complement their offshore patrol vessel, our patrol boat, and the major fleet unit ships, the frigates and the destroyers. And that is a really exciting project that is also running right now, aiming to bring those systems into service in the mid-20s. Air Force are also jumping on board. I said that they're experiencing large operations. We have done some small operations in Air Force as well. Our security forces, the people that patrol our Air Force bases and secure those air bases when we deploy, they have got into the multi-rotor game. They use the Sky Ranger R70, which is a Canadian product owned by Fleur. They use that essentially like Army does, but in a centralized airbase force protection role. And we're looking to bring those into service over the next couple of years. We've done the experiments and trials with these systems, and we're looking towards big capabilities spread out across all those units into the mid-20s. We're also using them for maintenance inspection. So, when a C-17 comes in for a depot inspection, you have to park it, then you wheel out a big bank of scaffolding. You have to qualify your people for working at heights. You got to suit them up in all sorts of fall arrest equipment and harnesses. You send them up, they do their physical inspection of the top of the tail there, and then they come back down. Well, we could save hours in the operation, we can save hours in training, and of course we can not put people in those risky working from heights situations by just using a drone. And we've used the Phantom 4 for doing this, and as you mosaic that together, that's shot in Ultra HD, and it's better than an airman's eyes, than a technician's eyes. And what's really great about this one is we could do Ultra HD change detection as well. So it's not just about sending them up for that one-off inspection. Now they can send them up, and before that airplane goes up, the technicians on the ground can have a look at the inspection from a month ago. And they can do a comparison as the airplane flies over. Afterwards, they can do a side-by-side matchup as well, looking for paint cracks, looking for any deterioration in leading edges. And we're really excited about this technology. We want to take it properly into service. We've already done some experimentation with infrared cameras and doing non-destructive inspection as well, so beyond just the optical spectrum. So that's really exciting too. We're doing that over the next couple of years. Air Force drone races as well. They're getting, and that top photo there is Air Force cadets, our youth movement. That's getting very competitive, and like I said, that next competition is going to be is going to be cutthroat between the three teams. We're looking forward to Air Force giving us a real run for Army's money. But here's where we get into the big end, billion-dollar programs. The first certified unmanned aerial system is going to be the MQ9B Sky Guardian from General Atomics. Are the first people that are pursuing this platform, and they're a couple of years ahead of us, but we have decided also to buy this aeroplane. We have collaborative agreements with the Royal Air Force and with the manufacturer, with General Atomics, and we will be bringing this into Australia in a fully type certified engineering campaign. By the mid-20s, their initial operating capability in 25-26 financial year, and we'll be gradually building that to 12 air vehicles over the ensuing years. Fully certified, so we can fly it anywhere in any class of Australian airspace. And I've highlighted in blue there a couple of the real big selling features of this aeroplane when held up against its predecessor, the MQ9A Reaper aircraft that many people will be familiar with. So this platform has significantly longer legs. It's a 30+ hour aircraft when it's in clean skin in ISR. Obviously, the time goes down if you load it up with ordnance, but in a surveillance mission, clean skin, or a humanitarian assistance mission, we can plan for more than 30 hours. It has a significant power upgrade, so 37 kilowatts available to payloads, to electronic payloads that you might bolt on. It has 9 hard points that you can strap ordnance or other electronic payloads to. And like I said, it's going to be fully certified. So it has a due regard system, so a forward-looking synthetic aperture radar mounted into the nose. It has ADS-B, it has TCAS, it has lightning protection, it is fully weatherized. We could fly it literally anywhere, and once we've finished that certification campaign, we can fly it in uncontrolled airspace with other air users around Australia. It's a super exciting project, and we're really excited to be partnered with the Royal Air Force on this one. The other big one's the Triton, the MQ4 Charlie. It is similar to the Global Hawk, but it is different. It's a naval maritime patrol variant, and that is a collaborative program that we've done with the US Navy. Top slide there is just to give you an indicator of the size. It is a commercial airliner-sized airplane, and then some of the stats are down the left-hand side. This is maritime patrol, so this is about providing surveillance of vast amounts of ocean around Australia and being able to detect the things we want to detect in our economic exclusion zone and our maritime approaches. It'll stay up for 24 or so hours, and it flies along at a very fast speed. Like I said, hoover the ocean of intelligence for us, and that's a pretty exciting project. We are fully approved for 3 now, and we have contracts in place for 3, and they will come into service in about the same year, in about 25-26. We'll see those flying around Australia's border patrol regions. And then we're doing a bunch of experimentation and innovation as well within Air Force. So Air Force is also very interested in pseudo-satellite technology. We're very interested in air teaming with our combat capability. So we have a significant 5th generation air combat capability with the Wedgetail, with J-35s, with Super Hornets, and with Growler electronic attack aircraft. We're very interested in loyal wingmen type activities. So unmanned air teaming air vehicles, and we've got a significant project scheduled for that into the future. But we've been doing some innovation and prototyping local with Boeing Australia, developing the loyal wingman airplane, and I hope you may have seen that on the news. That is going to fly in a matter of weeks' time as it kicks off its test and certification campaign. We're also doing a bunch of innovation through the Defence Innovation Hub and Air Force's own innovation network, which is Plan Jericho. And we're doing a lot of work into disruptive technologies, swarming activities, completely autonomous, long-range dropped UAS to help our air power campaigns out there. So to the future, so all of that's already happening. It's already in service. We've already got those concepts, but we're also looking right into the future, right out into the 2030s. Our force structure plan was just released by government, and across Navy, Army and Air Force, there is a raft of uncrewed capability projects. So Air Force, we have a project already for follow-on platforms, for contested ISR platforms, for loyal wingmen, for teaming air vehicles. In Army, we have already loaded replacement projects for the Battle Group UAS, replacement projects for the Wasp, and we're getting big into ground robotics and autonomous ground vehicles as well within Army. And Navy, I told you about C129 and their tactical UAS program. They're also getting into surface and undersurface capabilities as well. All that adds up to a very significant amount of expenditure for Australia going into the 30s, about 30 billion Australian dollars. And the way to get amongst that, you know, it's a decade away. Well, you got to start at the early stage of product development, and the following dot points, there are a range of mechanisms we have in place. So the Trusted Autonomous Systems Defence Cooperative Research Centre, that's run by our Defence Science and Technology Group. That is a bunch of universities and research and development organisations getting after really early technologies right now, stuff that we might see in service in 10 to 15 years' time. The Next Generation Technology Fund and the Small Business Innovation Research and Development Grants, they're for slightly higher, so things that actually exist, things that you can and start bringing together in a test environment. Defence Science and Technology Group run that as well. And then we have the Defence Innovation Hub. This is our mechanism for things that we can bring together right now. You know, maybe commercial products that could be militarized, or commercial products that could be reimagined into a military application. That's what the hub's for mid-level technology readiness level. And the case study there that I wanted to call out was our small UAS of the future. So like I said, we've been trying to seed Australian industry to compete for the replacement of the Wasp. We've already issued 10 contracts, more than $11 million out the door to Australian industry, what the next generation of a small UAS might look like. And then, of course, we've got the projects, like I said, about $30 billion in project money that's coming in the 30s that can pay for all of those technologies once they're mature and ready to bring them into service. It's a really exciting environment, especially if you like research and development. If you've got great early technology ideas in the universities at the moment, and if you like to see innovative applications, which I love, and a lot of those contracts I've been the contract manager on, they're super exciting. A quick plug, if you want to know more, there is a webinar coming up in a few weeks' time. If you're interested in knowing more about Australia's Defence Force Structure Plan 2020, just jump onto LinkedIn or onto the website for AAUS, the Australian Association for Unmanned Systems. We're running a webinar where our generals, Army, Navy and Air Force generals, will be talking about their vision for how that $30 billion is going to get spent. That might be an interesting opportunity for you. I hope the connectivity ran well enough, apart from that one little glitch, that you got all the slides and most of what I talked about. You can connect with me after the fact through LinkedIn or Twitter if you like, or if you want to follow awesome drone racing videos, jump to AUADART as the handle. That's the Australian Army Drone Racing Team. Great social media channel, that one, for some really cool videos. But right now, Sudip, I would be very happy to take any questions from the audience.
Great, thank you. So we have audiences in a mixed platform. So we have audiences here, and we also have audiences on Facebook Live. So please feel free to post your questions here in the chat box, or you can post it on the main page of AESN on Facebook, and we'll get to that. Yeah, so one after another. Keirin, I'll start with some of my questions, if you don't mind. So with regard to applications, right? So apart from the the tactical combat applications, so like what kind of search and rescue operations is the Army or the Air Force involved in? And so do you have some good examples, for example, with the bushfire and other calamities that we recently saw? So like, is there similar, some kind
Absolutely. So during our Black Summer bushfire period that we just had the worst bushfires that we've had in over 30 years here in Australia. A lot of our military was called out to support our emergency management services, and one of the capabilities that was called out was our unmanned aerial systems capabilities. So across the emergency areas, we had our commercial systems, so our Phantom 4s were sent out so we sent out a team, a pair of soldiers with one of those systems, and we also flew our Wasps as well. Now, the commercial ones, daytime camera only, daytime operations only, they were mainly used for damage assessment. So they're really great for getting overhead photos, for helping coordinates to find out where people's buildings were burnt out, where roads were closed, and doing those damage assessments, and even starting those very initial assistances to recovery as well. So we also helped out with insurance claims and things like that, being able to take really great videos to really rapidly assess insurance claims and get emergency money flowing to those farmers and people that lost their houses and things like that. The other one that was used extensively was the Wasp, and Wasp, you'll recall, had a gimbal day-night camera on board, so it has an infrared. And the way they used that was at dawn, just before all the aircraft started, so fire bombers and helicopter bombers, before all of them got airborne, what we'd do is the Wasp would be sent up at the crack of dawn with its infrared camera, and through infrared imagery, we would do high accuracy plotting of the fire fronts and mapping of the intensity of the fires and where those fire fronts were, so that they could coordinate the best application of those fire bombers once they were able to get time hours. That's how we used the ones we've got. What we're really excited about is some of the big ones that we've got coming. So, those airplanes were able to get up for 25 or 45 minutes at a time. What we're really excited about is platforms like the Sky Guardian, an airplane that can stay up for 30 hours and at 25,000 feet in an orbit, just stay there doing continual update in high definition infrared technology that's with high accuracy georeferencing to the emergency management organizations. That will be a really exciting capability when it comes to bushfires in the future. But we also think that platforms like the Triton and the Sky Guardian will also be used in particular maritime search and rescue, being able to cover large distances for long endurance synthetic aperture radar and very high fidelity imagery that is augmented with edge computing and machine learning technology built into those algorithms to pick things out of the ocean or out of large bush or desert areas, things like that. The applications are huge, and it's going to be very exciting to see how our operators adapt military techniques and procedures, those humanitarian assistance and disaster response scenarios.
Okay. Thanks for that answer, Keirin. Also connected to that, I have my second and also last question until I get back to other people's questions. So with regards to, like how much unmanned aerial systems are effective in helping out perhaps with ground troops or even with the pseudo-satellite technology with the US that we are talking about, so like so far with, I guess, a decade or more of continuous US operations, is there some, insights already on how effective and how much of an improvement drones have brought about?
Oh, yeah. There's so many examples.
Right. Okay.
All right. So I'll just pick a couple, right?
Yeah.
I'll pick three good ones that are unclassified, that are really interesting examples. So let's start with the tiny one, the Black Hornet, right? So Black Hornet has the ability to look forward and look for things, but it also has a downwards looking camera. So a pair of soldiers, armed just as they walk with some radios and a Black Hornet, they can now go out into places, go out on a patrol, and they can fly their Black Hornet out to 2 kilometers away. And when they see something, they can then fly that airplane over the top of it, go to downwards looking camera, and then the airplane will provide them a 10-figure grid reference of what they're looking at.
So I think a lot of us, I think I've seen Black Hornet, I've had the pleasure of holding one in my own hand, but I think a lot of our presenters attendees don't actually know what a Black Hornet looks like. Could you go on the slide where there's a photo of Black Hornet?
Oh yeah, sure.
Thanks.
Let me go back to, here we go.
I think it was in one of the first pages, I believe.
Yeah, it was. But all right, here we go. So yeah, it doesn't want to go back.
Oh, yeah, so we can't actually see your full presentation.
All right, so let me just talk while I find it.
Yeah.
So it provides a 10-figure grid reference for what it's looking at. That means that now a soldier or a pair of soldiers can then provide that 10-figure grid reference into a battle management system, into a fires system, and they can coordinate the engagement of that target, or just telling everybody else where that target is. Now that's a capability that a pair of soldiers never used to be able to have, and that is significantly enhancing. So this is a Black Hornet. You can see it on the right hand side. Its entire kit packs into that pouch that's worn on the chest, and you can see at the bottom of that pouch 2 thin containers. The airplane fits inside that. So the one's flying, 2 are on charge, and it's all controlled just with a hand control. And the way the soldier is taught how to do that, because it's single hand controller, they're taught to use their non-firing hand. So if they are in a close arrangement where they still need to be able to protect themselves, they can still have one hand on their weapon, but they can still be flying an unmanned aerial systems mission. So it is literally that big. It fits in the palm of your hand. It's only 30 grams, and it can fly out to 2 kilometers away. So that's that kind of technology. So that's a really good example, right? So we don't have to send a soldier into an intersection now to have a look into a really dangerous area. We don't have to send a soldier over a hill. We can send a robot to go to fly over the hill and have that look, and that is a significant efficiency dividend. You mentioned pseudo-satellites. So Australia is not a desert country, despite what many people may think. It is actually quite mountainous in regions. And when you are operating in mountains with combat net radios, so UHF and VHF frequencies, they are line of sight systems. So if a mountain is in the way, you can't talk to the other people on the other side of the mountain. Well, what the pseudo-satellite capability gives us is the ability to put a communications rebroadcast at 70,000 feet. Do you know how much distance, how much retrans bubble you get if you're flying at 70,000 feet? So a VHF radio transmission can go 250 kilometers up and down again. So an airplane like this can make mountains, from a communications perspective, can make mountains disappear for a 300 to 500 kilometer radius of action. And that is a huge efficiency dividend, because we don't have to put out retrans stations at the tops of mountains to fly, you know, small, short endurance missions with radio retrans equipment on them. We can put one of these up, leave it there for 30 days, providing that massive bubble worth of rebroadcast for our radio system. So that's another one of our effectivenesses. The other one I want to talk about is off shadow, right? So shadow is old, it is clunky, it is noisy, but even the noise can be effective, right? So when you're on operations, especially in an insurgency environment, you know, insurgents launch rockets at you, they launch mortars at you. Well, we have the ability to plot those over time. Launch locations are. Well, one way to stop them using that is to overfly those areas regularly with a really noisy drone, because they think that if a drone's over the top, they can be seen and they can be targeted. So even some of the older, really noisy systems can still be used to great effect. We fly them low to make them really loud over places like that, so they won't use them. They won't occupy them as launch sites. Of course, at the same time, we can just, on the next thing that airplane does, we can just push it up in altitude and make it nice and quiet, and it goes about its covert mission as well. But we can use them overtly as well. So there's examples of some of the effectiveness of systems like this.
Great, thanks. So we have a few questions here, and someone just sent me a question on Facebook. I'll come to the questions here first. So Vinod asks, hi Keirin, do you think someday in future, Air Force will completely move from manned aircrafts, for example, fighter jets, reconnaissance aircrafts, to unmanned systems only? So is there a move happening at some point?
You know, I would like to think that is the case, Binod, but I think it's going to be quite a while away yet. There's always an excitement factor with new technology, and you know, doctorates have been done on it, right? Tracking new technology and how long it actually takes to bring into service. The fact is that fully embracing new game-changing technologies usually takes a lot longer than we first get excited about it. While we can, and yeah, a really great example was 3 weeks ago with DARPA, right? DARPA ran their dogfight competition where they had an AI versus a real F-16 pilot, and the aircraft characteristics were the same, and the AI won 5 out of 5. But it was a really old example, and you know, AI can be trained for really neat, tight examples at the moment, but it doesn't have machine learning, and AI can't think creatively yet. Even in the Go or chess examples, really constrained boundaries, really rules bound, and the AI wins. But as soon as you need to be creative, computers just fall apart. So I do think it's coming, but I do think it's still quite a long way away. There are many, many computer science and AI PhDs that need to be written and explore those boundaries before we see people removed from cockpits.
There's some motivation for students to work on AI and UAV.
Heck yeah.
So we have another question from Ayushma. Hello, Keirin. Thank you for a wonderful presentation. I'm just reading word by word here and here. Do you think there is a future for 3D printed drones? And is Australia working on or researching on any 3D printed drones?
Absolutely. So one of the reasons we've invested in the drone racing team, those guys and girls are already 3D printing their own parts. You know, props can be 3D printed now. The individual housings for mounting GoPros and cameras and transmitters, they're all 3D printed by by those drone racing pilots. We've already experimented. The disposable drone that I showed you, the cardboard one, its avionics is fully 3D printed. Obviously the circuit boards aren't yet, but they're working on that as well. 3D multi-additive component, 3D printing of electronics as well. That's coming. The US Marine Corps have a program that they call Quads for Squads, where they have multiple designs. As you prepare for a mission, you go down into the belly of your troop ship where the 3D printing lab is, and you say, all right, I'm going on ops in a week's time. I want 10 ISR aircraft. I want 10 explosive aircraft, and I want 10 mapping aircraft. And they just print them out, and they're simple enough that the soldiers can then just grab a bag of electronics and put them together. I absolutely think that 3D printing and additive manufacturing will be a big part of the production revolution that's coming for components like this.
Thank you. Okay, another question from Jeevan is, hi Keirin, with regards to the pseudo-satellite, can those satellites be used as missile defense alarm technology within the range of the satellite? That would use infrared sensors and a telescope. So with a sensor, would that be a deterrent type of technology?
So yes, but not quite yet. So pseudo-satellite technology at the moment is still very constrained by space, weight, and power for payloads. And the Zephyr, it only lists 5 kilograms at the moment worth of payload. 5 kilograms is not a lot of payload when you consider electronics, data links, and the lenses, quite heavy component lenses that go into the kind of fidelity that's required for missile defense. But I think it's coming, right? So missile defense and missile detection technology is already being prototyped, and this is open source on commercial airliner scale airplanes. USAF and other countries have tested those kind of payloads and detection cameras on 747s and Airbus platforms. The General Atomics, who make the Reaper and the Sky Guardian, they have already prototyped a variant or done the conceptual design work for a variant that is a missile defense. Flies around for 30 hours a day, just pointing infrared optics at the ground. So right now, you still need a big airplane to lift those kind of payloads. But as payloads shrink and as pseudo-satellite airplane technology increases and they are able to lift more and stay up for longer, I think there will be a convergence, and that may well be one of the missions that planes are tasked with.
Thank you. So we have a pretty long question, but it's also, I think, a hypothetical scenario that Rahul has created here. Imagine a defense operation in which a drone is sent out to spy on enemy territory. The enemy identifies the drone, but instead of disabling it, compromises the sensor to inject false data. Acting upon such data could then result in inappropriate tactics, and in a worst-case scenario may even lead to unavoidable casualties. What ensure military drone security, and what technology is specifically there to prevent aerial threat?
Okay, so let me start with saying that deception is not new to the military, right? We have been putting decoys on battlefields for as long as we've been fighting battles. This is just the latest evolution of counter and counter techniques that militaries use to try and gain an advantage. So specifically to the cyber worthiness platforms, though, that is absolutely a concept that that militaries will explore, the ability to hack into a system and use it in a counter method, a counterintelligence or a counter targeting method. What can we do about that, though? So things that the Australian Defence Force does as it acquires any tactical system is we have requirements for cybersecurity and encryption of data links, and we test that. We don't just ask for it and then trust that the people that build it will deliver that. We also put it through a very thorough cyber vulnerability assessment as well. All of those grey systems that I showed you, all of them have a level of cyber protection to them. So the Black Hornet runs an encrypted data link. So not only do you have to be able to match the frequency, because it hops as well, it doesn't just stay on the same frequency. So you need to know the hopping mechanism, the hop algorithm, but then if you can do that, then you've got to hack its encryption on board as well. And we have varying levels of encryption depending on how important the system is. So some systems will just have, an AES software-based encryption, like your mobile and your banking application. Others will have a crypto device on board that has to have a controlled cryptographic key loaded on it. And that has to be updated and controlled. So we do proof them, we do test them, and we do set fairly specific requirements for what that is, those pieces of equipment have to have.
Okay, so sort of a related question before I go to the final question that's been asked to me on Facebook. So a related question was, so in hypersonics, for example, the field that I work in, we're now talking a lot about counter hypersonics. And inevitably, the first hypersonic vehicles, as much as we want to build reusable commercial hypersonic vehicles, are going to be unmanned. And they will probably be built in a way that they won't be returning back to the base. So like with regard to counter hypersonics, or in general counter unmanned aerial vehicles, so what kind of technologies do you think have been sort of have reached a saturated state, or do you think it's of some concern even for a civilian airspace at the moment?
Look, yes. So just like the military, so you said civilian airspace, thinking creatively about how to apply technology for good and bad purposes is not limited to the military. There are plenty of civilians out there, or troublemakers and terrorists that are thinking about ways to apply this technology in bad ways, and then subsequently, military and police forces also have to think about ways to counter what those systems might be used for. Yes, there are a range of counter unmanned aerial systems, counter missile, counter hypersonic technologies that are out there, and that is almost a lecture in itself. The different ways you use these systems, but I will sum it up reasonably quickly. There are two challenges: detection and then doing something about it. Detection and reaction. From a detection perspective, there are many ways that you can detect UAS missiles, from optical to radar to acoustic to other elements of the electromagnetic spectrum. So there are a range of technologies to get interested in for those that are in university or are looking for graduate or undergraduate research projects. There's a range of technologies that for detection, and then there's treatment, the reaction, and that can be loosely described into kinetic and non-kinetic. So kinetic, you can shoot it down, right? You could put something else up there that destroys it, and there are many ways to do that, from your own hypersonic systems to missiles to bullets to nets. There are many ways to counter it from a kinetic perspective, and there are many ways to counter it from a non-kinetic perspective. And that harks back to the last question. One of the non-kinetic ways is you can hack their system and capture its guidance system or its control system, and you can put that airplane where you want it to go instead of where it's meant. You can jam it and just make it completely confused and fall out of the sky. There are different non-kinetic ways you can treat it as well. It is a very exciting field, counter UAS. I think one of the reasons why it is very exciting from a technical perspective is that counter UAS is not just about military applications. There are many commercial reasons why you would want to be able to detect and then do something about a commercial or a hobbyist or a nefarious application in the commercial space. But it is a very interesting area. If anyone wants to get into that, it's got many decades worth of work ahead of it.
And so I think the last question, Keirin, we're almost out of the way, are actually out of time, but this will be the last question and then we'll go towards the closing. So I think the questioner, so you shared that photo of UAS, I think they were Phantom drones inspecting C-17s. And so with regard to those kinds of maintenance inspections, so are they applicable in any way currently to civilian airliners as well, or do you think it's only limited to military applications due to regulations? And also connected to that regulation question is, so similar to how there's ICAO and there's EASA and other regulatory organizations internationally, so will there be a need for having a international body that regulates UAS operations because the development has become, sort of non-industrialized and also easier for people to develop?
I think you're cheating there, Sudip. I think that was 4 questions.
Sorry. I mean, it's a long question. I kind of paraphrased a few things, but
Yeah. So first up, maintenance inspection. We are not pioneering this. In fact, the civilian sector and civilian airlines are actually leading the technology development in aircraft maintenance inspection. And the example that I gave, a C-17 outside on the tarmac, many of the civilian applications avoid that arrangement, the regulatory arrangement of flying a drone in open airspace around an airport, but by them, they're huge maintenance hangars, right? And so they do it even better. So they will wheel, they will tow an airliner into one of the large maintenance hangars, and then because it's fixed infrastructure, you can set up differential GPS guidance or other forms of very, very accurate guidance, and they can automatically program their drones to go through human on the loop, not in the loop, and do it automatically. So, and even see dividend in the commercial sector, and they are also the ones leading the next steps, and not just using optics, but using infrared and multispectral to do non-destructive inspection to see underneath the skin of the aircraft, and not just leading edges and paint. So the civilian sector is absolutely driving that, and any solution that we adopt will probably be demonstrated as industry best practice by Lufthansa or Qantas or somebody like that. To the regs, we are blessed in the Australian having our own regulatory authority. So in Australia, the Commercial Aviation Safety or the Civil Aviation Safety Authority governs our airliners and our general aviation and whatnot. We have a parallel organisation called the Defence Aviation Authority, and we write our own regulations. Now, we have actually chosen, both organisations have actually chosen to adopt the EASA standard, the European Safety Association's standards for implementation in Australia. So we actually talk EASA really well in Australia, and we tweak them to be specific to the Australian environment, but generally the structure is exactly the same. Do I think there's a role for an international regulator for drones? KO have already taken up that that deficiency. They are already working on international coordination of UAS regulations. Yeah, the FAA have done their own thing, but EASA are definitely doing their own thing, and is trying to bring them together and talk a similar language. I think where we'll really see development in the regulatory environment is just around the corner. So as we bring in the first certified large drone, the Sky Guardian, and that will be bought by countries in Europe, Australia, Asia, America. As that happens, we will take that certified platform, which is being built to a NATO aircraft design standard, that will become civilianized, and those civil organizations will then have an exemplar to follow for what certified platforms look like. I think the other thing that's really going to drive it is parcel delivery as it continues to pick up pace for small drone certification, and then the urban air mobility market as unmanned aerial taxis really hit that technical maturity level and start being really adopted across the globe. I have no doubt that an international design standard will also emerge and need to be coordinated for those. Because whoever cracks the market first with a certain, they're going to want to go global as quickly as they can, and they'll need an international recognition for that. And I think ICAO and probably EASA will be the people that drive that through.
Thanks so much, Keirin. I think that's the end of the questions as well. So we will now move towards the closing of the session. And so to close the session and I'll talk about the association as well, I'll invite the president of the society, Mr. Ashish Mananda. But before that, I want to quickly mention that please keep in mind that this is a membership-based organization like any other organization, and it's very valuable to us that people, professionals and students, be a member of the society. And to do that, you could visit our website, which I've shared in the chat box here at the very top. And please look up. And if you have any question, please send us an email. And I think with that, I will now hand this over to the president of the Aeronautical Society of Nepal, Mr. Ashish Mananda, to give his closing remarks, and then Keirin will be doing the end of the session.
Okay, thank you, Sudip. Yeah, thank you very much, Keirin, for the wonderful presentation. I hope our attendees today got to know about the Australia's Defence Force Unmanned Aerial System. Like, they got to know more about even though we have those things on the internet and everything, so it's basically good to know from the one who is inside. Yeah. So again, I'd also like to thank Sudip for introducing Keirin to the Aeronautical Society of Nepal, and also moderating this session. Thank you for sharing your thoughts, Keirin, and I'd like to thank all the attendees once again. Yeah, and again, for the future events, you can visit our website aerosocietynepal.org, and we are also on Facebook as Aeronautical Society of Nepal. Yeah, thank you very much.
Thanks. Okay, so with that, I will now hand this over to Keirin, but I also want to thank Keirin for several things, including the fact that he accepted this presentation again. And I think this was very, very new to us. I did not emphasize this in the beginning of the presentation, but just hear from people directly working in the field, working with these machines. And I was hoping to hear a little bit more about the loyal wingman, but perhaps it's not the time yet. Maybe sometime in the future. But with that, Keirin, thank you very much again, and I will let you close the session with your closing remarks.
Thank you, Sudip. Thank you, Ashish. It is a pleasure to have been here. I think you will be able to find more out about Loyal Wingman early next year. I think we'll keep it close hold until it flies successful. but everything is looking very good from its test and evaluation campaign. It is my pleasure. I hope your UAS students are inspired by the technology that is being developed and by the challenges that are around the corner. And I hope that that everything Aero Society Nepal continues to do great things. It is an inspirational story about how you come together and developed your academic and then research and development technology capability. Countries like Nepal, those efficiency dividends are just waiting to be tapped. So I wish you all the best of luck, and thank you again for inviting me.
Thank you very much, Keirin. So I'll stop the recording, and thank you very much, everyone. Thanks, Keirin.
Goodbye.
Thank you.
Bye-bye.
Bye.